All right, picture this. You have exactly 20 minutes before your Cambridge Information Technology 9626 mock exam begins. The invigilator is just about to hand out the papers. You mentally turn your focus to the section on control technologies and actuators, and suddenly it hits you. You realize you don't actually know how to apply the theory to a real question. 0. Yep, that is the exact number of marks you're going to get if you write down generic, unanchored answers when that paper hits your desk. Okay, let's dive into this. The Cambridge mark scheme is absolutely ruthless when it comes to this specific topic, and just memorizing definitions, well, it just won't cut it. Section 1, the generic answer trap. So, what's the fundamental disconnect for so many students? Well, it's this. Generic points rarely gain full marks. You might know all the theoretical terms perfectly, but if you fail to apply them to the examiner's specific scenario, whether it's a smart greenhouse or, say, a secure hospital system, just naming a concept is a guaranteed way to lose easy marks. They want real application, not a textbook copy-paste. Section 2, the illusion of competence. Now, before we hand you the ultimate examiner clue that changes everything, we really have to clear up a dangerous situation. I call it the illusion of competence. See, in a control system, you need real-time direct data. Think of a temperature sensor feeding straight into a microprocessor. Do not confuse this with indirect data gathering, like looking up static information in a database. If your exam answer even implies a delay, you've completely missed the core concept of real-time control. When you're analyzing these control technologies, you absolutely must connect the right method to the input stage. Sensors represent direct automated input. If you mix this up and describe, a human entering data on a keyboard when the scenario clearly asks for an automated system, you literally forfeit those marks right on the spot. Which brings us to another classic wrong turn. I see this all the time. Storage devices. Ask yourself, what does a hard drive have to do with control technologies? The answer is absolutely nothing. Students frequently confuse long-term storage media with the immediate physical output of an actuator. An actuator is a motor, a valve, a robotic arm. It performs a physical action out in the real world. You have to keep them separate. Next up is software. Look, it's great to know your proprietary and open-source licensing models, for sure, but control processing logic is distinctly different from buying off-the-shelf software. Don't waste your precious extended response talking about open-source licenses when the examiner is actually asking you to evaluate the algorithmic logic of a microprocessor. Another huge pitfall involves user interfaces, like dialogue and gesture-based interactions. Human-computer interaction is fascinating, don't get me wrong, but control technologies often rely on sensors that operate continuously and automatically, completely independent of human interaction. If your answer focuses on how a user swipes a screen rather than how a sensor triggers the microprocessor automatically, you miss the control part of the whole shebang entirely. And don't even get me started on verification methods, because they frequently get dragged into wrong answers too. You have to strictly distinguish between verification, like double data entry used to check human typos, and the continuous physical monitoring of control systems. A sensor doesn't verify a temperature by typing it twice, right? It just reads analog data continuously. Let's wrap up this whole illusions section with operating systems. An OS manages general hardware and software resources for a computer system. However, a control system specifically orchestrates sensors and actuators for targeted real-world scenarios. If you use general OS terminology instead of the specific input-process-output sequence of a control system, your reasoning just falls apart. Okay, the illusions are officially cleared. Let's move on to the actual solution. Section 3, the 4-prompt framework. Now that we've cleared away all that confusion, here is the promised examiner framework. This is the ultimate tool that guarantees top marks by building an unbreakable chain of technical reasoning. Grab a pen, here is your actionable checklist. 1. What is it? Define the specific technology. 2. How does it work? Explain the exact sequence. 3. Where is it used? Anchor it to the exact scenario. And 4. Why is it better or worse than the alternative? You need to confidently answer these 4 prompts aloud in your head before your pen even touches that exam paper. Section 4, spot the error. Let's put this brand new framework to the test and see if you can spot a Cambridge-level error. Listen to this classic, heavily flawed student answer. Sensors read data and the actuator does the action. Take a second. Why does this completely fail the Cambridge standard? Well, I'll tell you. It fails because it ignores the microprocessor entirely, it completely omits the analog to digital conversion, and it is just incredibly vague and unanchored.
Compare that absolute fail to this top band correction applied to a greenhouse scenario. The temperature sensor reads analog data, converting it to digital via an ADC. The microprocessor compares this data to a preset threshold. If it exceeds 25 degrees, it sends a signal to the actuator to open the windows. See the difference there? We hit how it works and where it is used perfectly.
This aligns directly with a core mandate straight from the source material. Show links to real-world workplaces, hospitals, and transport systems. This exam is testing your adaptability and your high-level reasoning. Applying your knowledge to these dynamic contexts is the ultimate key to proving you actually understand how IT systems function out in the real world. Section 5. The mandatory next step. But wait, let me escalate the stakes one last time for you. The 4-prompt framework we just covered is incredible for basic applications, absolutely, but it's only going to get you halfway there. Which brings us to a critical final question. How do you evaluate a control system when the examiner completely changes the scenario midway through the question? To survive your mock exam and push into those elite top band marks, you need a completely different strategy. Watching our next explainer on the top band evaluation framework is absolutely mandatory. Subscribe to Ace the Exams to excel in your Cambridge examinations. Your mock survival plan continues next. Just click the explainer on screen right now and I'll see you over there.